What? Hello? What? Wait. I literally clicked it on the minute. Hello, J. Biden 4. Hello, everyone. I'm just making sure everything is running with all the stream stuff. Make sure my audio is all good. Can you hear me fine? What? I was late by 1.3 seconds. Also, thank you for the cheer, Nitro. That was quick. Okay, so we should be going. Let me make sure. Channel, there we go. Everything should be going. So, hello everyone. Oh, but I'm getting feedback. There we go. Hello everyone. I'm Froox, and welcome to the third episode of the Resonance. Oh my god! Thank you so much for the cheers, emergence and temporal shift. Hello everyone. This is the third episode of the Resonance. It's essentially like a combination of office hours and podcasts, where you can ask anything about, like anything about the Resonite, like whether it's its development, philosophy, how things are kind of going with development, its past, its future, where it's heading. The goal is to have like a combination of Q&A, so you can ask, questions, whatever like you'd like to know. I try to answer to the best of my ability. And we also have, I'm hearing that the microphone sounds windy. Let me double check that OBS didn't switch microphone on me again. Test 1, 2, it's in front of my face. Properties, yeah, it's using the right one. Is it understandable? It's really strange. Like, it should be compressing it, like... I mean, it's a wireless microphone, but it's like its own custom thing. But anyway, let me know if the voice is like okay, if it's understandable. Anyway, so you're free to like ask any questions, and I'm also like do kind of some kind of like general kind of talking about the high level concepts of Resonite, where it's past it, what its future is gonna be, which direction we want to head it, and so on. One thing, if you want to ask questions, make sure to put a question mark. Actually, let me double check. Oh, I didn't save the version with the auto add. Auto pin. There we go. Okay, now it should be working. Make sure to end your question with a question mark. That way it kind of pops on my thing. And we already have some like popping up. So with that, we should be good to get started. I also might switch this camera just like this. There we go. So hello everyone. Hello. Hello, I'm bad at names. K. Hello Troyborg. Hello Lexevo. So we actually got first question from Lexevo. Do you think you'll have any other guests on your show that might focus on specific topics? It's possible. Like, the goal of this kinda is kinda like, sort of like my kind of office hours. So that like this is probably gonna be like the main focus. But I'm also kinda like, playing with the format a bit. Unfortunately, Syra couldn't, like, I usually have Syra co-hosting because we cannot have good back and forth. It's on the technical things and sort of like, the philosophy of Resonite. But I kind of like, I don't see where it kind of goes, because I had like some ideas, and for the first two streams that like I did, there was like so many questions that we didn't really get much to the chill parts of it. So I want to kind of like explore that. We might have like some like other people as well, kind of talk to them about like specific stacks of Resonite, but I don't have any super specific plans just yet. So we'll kind of see. Like, I wanna at least for start, I kind of wanna keep things simple. Take it like essentially with baby steps. But I feel like probably like at some point I'll start like bringing like more people as well, so we can kind of talk about like how some stuff has been going and so on. But I'm still kind of, you know, figuring things out. So the next question is from Emergency Temporal Shift. What is the funnest particle? And it kind of depends. Like, I don't know if you can get like a maybe like the thing that immediately comes to mind is like, you know, particles that will make sounds, but that's one of the things you cannot do right now. You make like a particle that, like, you know, does like some kind of funny splat sound, or goes like boing every time is it like, you know, bounces or something like that. There's actually kind of interesting thing, because like it's a request we got in the past, is, you know, I'm kind of going over tangent right now already, where you can or people want to, like, you know, particles to make sound when they collide with something, or they generally want events so they can react. The only thing is particles, the simulation runs locally on each person, so it's not like 100% in sync. The people will be seeing similar things, but not exactly the same. So like you may have, like, you know, clump of particles, and one goes like, one might, you know, go like this way, and for the other person it goes this way. So if you have like one person handling the events, then something might happen, you know, so like say like for me the particle hits here, and for the other person it hits here. So if you do some event at this point, then it's going to be like in a bit of a disconnect for other users, because for them the particle hit over here or maybe just missed. And it's kind of interesting problem. And one way to kind of approach that kind of thing is make sure effects are only things that are local. So like, for example, local sound, that way everybody, you know, say if I do like bubbles, and if you, like, you know, bop them and they pop, you will hear the pop sound, and it's going to be kind of localized mostly to you. And if it's like similar enough, like it's just going to be close enough that people will not notice. But it's a curious problem. And kind of a little bit of tangent for the question. So the next one we have JViden4 is asking, I was confused by the stress test. The announcement said it was around oddnet 8 as opposed to oddnet 9. Was that a typo, or was meant to establish a baseline? So it was kind of neither. We have like net 9 headless ready. We kind of wanted to, like, you know, push it, like already, like give people time to prepare. But under the team running the event, they decided to go with the net 8, you know, for the testing. And the main test wasn't even the performance of the headless itself. It was make sure that the hardware is running on and the connections is running on is able to handle the event. So the focus wasn't as much, you know, testing the performance of the headless itself, but more kind of, you know, combination of hardware and make sure we are ready for the event, you know, with the setup we have. And it was also like one of the reasons is because we wanted the event to be as flawless as possible. The team decided to go with, you know, with net 8, because the net 9 is, you know, it technically isn't released yet. So we kind of, you know, stuck with that. Even though like you know, the probability of it breaking things is very low, we just wanted to like, even if it was like, you know, 1% chance that something might break, we wanted to eliminate that 1%. Clevin VR is asking, is there any focus on actual tutorial on Resonite? New users suffer from not understanding the dashboard, how to find avatars, and how to find people. This seems like an easy thing that can be delegated out and does not need to take up any of your bandwidth. Yes, there's actually something that the content team is largely working on. They've been kind of like looking at, you know, ways to kind of improve the tutorial experience and overhaul some parts of it. So even the existing experience that we have has already been mostly delegated. There's kind of parts of that because, like, getting new users to the platform, it crosses lots of different systems, because when you start up, you know, we want to make sure that, you know, the user has an account, that like their audio is working. So we kind of, you know, guide them through like the few initial steps, and it's a part that's more, you know, on the coding side. So that way, you know, if there's problems with that part, or there's something we need to add to that part, then it's to be handled by, you know, our engineering team. Then the user gets brought into the inward tutorial that explains things, and it's mostly handled by the content team. And we also had like Ariel, who's our like who's a like new like person like handling a lot of marketing stuff and development, like, you know, communications and so on. She's been kind of like looking, because she's relatively new to Resonite as well, so she's been kind of using that perspective to be like, you know, this is what we could do to smooth out, you know, the initial user experience. And she's been talking with the content team And we're kind of looking, how do we improve that experience to reduce frustrations for new users? And there's like definitely a lot of things you could do. The only part is like it's always difficult. Like I wouldn't say like it's a simple thing to do, because you always have to kind of balance how much information do you give the user at once. And in the past, we tried approaches, where we told them about everything. There's like inventory, there's contacts, there's, this thing and this thing and this thing. And what we found ends up happening, a lot of users, they get overwhelmed and they just kind of shut down. And then they they will not even understand the basic bits. Like they will not know how to how to grab things, how to switch like locomotions. So you kind of have to ease the users into it, kind of, build upon like simple interactions, and building those kinds of tutorials that takes a fair bit of time. There's other aspects to this as well. For example, one of the things that people want to do when they come in here, they want to set up their avatar. And the tricky thing with that is that requires, use of advanced tools like the developer tools and so on. It requires use of the avatar creator. And the avatar creator is something we want to kind of rewrite, but that's an engineering task, that's not something that the content team can do right now. So there's a lot of kind of like, aspects to this. It's like where they can build better tutorial for some things, but some things do require some engineering work. And we kind of have to like, design things in a way that we don't also want to like avoid wasting like too much effort on certain things, because we know, we're gonna rework stuff like the UI, like, in the inventory UI is gonna be reworked at some point. So then it becomes question, how much time do we invest into the tutorial for the current one when we like, gonna replace it? So some of those parts, we might just do like a simple tutorial and do like better one later on once the engineering tasks gonna come through. So there's just a lot of, complexities to these kinds of things, and it takes time to kind of like improve them. What helps us the most is, getting information about what are the particular frustration points for new users. If somebody new comes to the platform, what do they get stuck on? What do they want to do? Like what's their motivation? Because if we know, okay, the user wants to set up their avatar, we can be like, okay, we're gonna put things that kind of direct them in the right direction. But also like, with the avatar setup, there's always kind of combination, like, how do we make the tooling simpler so we don't need as much tutorial for it? Because one of the things we did a few months back is introduce the Resonite packages, and if there exists a Resonite package, for the avatar that the user wants to use, they just drag and drop, and it makes the whole process much simpler. We don't have to like, explain how to use the developer tool, how to use the material tool. You literally just kind of drag and drop, and you have like, simple interface. But that doesn't work, in 100% of the cases, so it's a particularly kind of like, challenging problem. But yes, it's something we do talk about like on the team. It's something like that's important to us. We want to ease in like the onboarding of new users, make them as comfortable as possible, and we're kind of like, working at it from different fronts, like both from engineering and from the content side, as well as, marketing and communications. Let's see. So Jack the Fox author is asking, my question for today is about Protoflux. In what direction do you want the language to evolve going forward? What future language features are you looking forward to? So there's like a bunch. There's actually, how do I put it? The funny thing about it is like if I look at the actual, future of like scripting in Resonite, it's actually not just Protoflux. One of the like, things about the way I kind of view like, visual scripting is that it has like its drawbacks and has its benefits. And one of the drawbacks is like when you write, really complex, when you write really complex behaviors, it gets a lot harder to manage, where, typical, text-based programming language might be simpler. But one of its benefits is like it's very, hands-on. You literally, drag wires. If I want to, control these lights, I just, pull out things from this and I drag wires, and it has a very hands-on kind of feeling. It's very spatial. And the way I can imagine the optimal, way for this to work is to actually be combined with a, more typical text-based, like a programming language. Where if you have like a lot of like heavy logic, like a lot of kind of complex behaviors, it's like, it can be much simpler to kind of like, like code things like that way. But then if you want to like, wire those complex behaviors into the world, that's where, visual scripting can come in handy. And I think we'll get the most strength by combining both. And the way I wanted to approach, the typical text-based programming is by integration of WebAssembly, which will essentially allow you to like use lots of different languages, even languages like C and C++, using, with those you can, bring support for other languages like, Lua, Python, lots of other languages, write a little bit complex code, and then some of that code might be exposed, as a node, and that node you kind of wire into other things, you do like, maybe little extra operations. It's almost like, if you're familiar with electronics, it's almost like having like, integrated circuit. And integrated circuit, it has a lot of the complex logic, and then it could be, written in a typical language, compiled into a WebAssembly module. And then like, the integrated circuit is going to have, a bunch of extra things around it that kind of, wired into inputs and outputs and make it easier to like, interface with things. So to me, that's like, the most optimal state, like where we have both and we can combine them in a way where you get the strengths, of each, and weaknesses of neither, essentially. That said, there are definitely things we can do to improve Protoflux. The two big things I'm particularly looking forward to are nested nodes. Those will let you, kind of create like, essentially package like functions. You'll be able to like define, if I kind of want to draw this one in, so let me grab my pen. I should probably have done this at the start, but I kind of forgot. Let's see. I'll try to use this one. I'll see if I move to the... If I end up moving... This is probably gonna be too noisy visually. I'm gonna get up and let's try this. I'm gonna move this over here. Hello. So, make sure I'm not like colliding with anything. So like the idea is you essentially define, a node where you have like, your set of inputs. And this is kind of like, my kind of thinking for like the kind of interface. So this would be, your inputs. So for example, you can have, like value inputs, you can have like, some impulse inputs, and you have some outputs, it could be values as well as, impulses. And then like inside of the node, like you can do like, whatever you want. Maybe this goes here, maybe this goes here, this goes here, and this goes here, and this goes here and here, and then this goes here. Or maybe like, I don't know, maybe this goes here and this goes here. And once you define this, you essentially, this becomes its own node that you can then reuse. So you get like a node that has, the same interface that you defined over there. And this is sort of like, the internals of that node. And then you can have instances of that node that you can use in lots of different places. With this kind of like, mechanism, you'll be able to, package a lot of common functionality, into your own custom nodes and just reuse them in a lot of places without having to copy all of this, multiple times, which is gonna help, with performance for Protoflux, because the system will not need to like, compile essentially the same code multiple times, but it'll also help, with the community, because you'll be able to build libraries of, Protoflux nodes and just kind of distribute those and let people use a lot of your custom nodes. So I think that's going to be particularly, big feature for Protoflux once this kind of lands. It's something that's already supported internally by the Protoflux VM, but it's not integrated with Froox engine yet. There's other aspect to this as well. because once we have support for custom nodes, we can do lots of cool things where this essentially becomes like a function, you know, like an interface. So you can have systems. You can have systems like, for example, the particle system that I'm actually working on. And say you want to write, you know, a module for the system. The particle system could have kind of bindings that accept, you know, they essentially accept any node that, for example, has like, you know, it has like 3 inputs. Say, for example, like, you know, position, say lifetime. That's like how long the particle has existed, and say direction. And then, like, you know, we have output, and the output is a new position. And then inside you can essentially do whatever math you want. And if your custom node follows this specific interface, like it has these specific inputs, this specific output, it becomes a thing you can just drop in as a module into the particle system, you know, to drive, you know, the particle's position, for example, or its color, you know, or other properties. And you'll be able to, you know, package behaviors and drop them into other non-Protoflux functions, and kind of, you know, have essentially a way to visually, using the visual scripting, define completely new modules, you know, for the particle system. But it expands beyond that. You'll be able to do, you know, procedural textures. Like one node that you might be able to do is one, you know, with interface where you literally have 2 inputs, or maybe just 1 input even. Say, like, you know, the UV, that's the UV coordinate and texture, and then a color. And then, like, you know, inside, like, you do whatever, and on the output you have a color. And if it follows this kind of interface, what this essentially does is you get if you have a texture, you know, that's like a square. For each pixel, your node gets the UV coordinate and it turns it into a color. So if you want to make a procedural texture where each pixel can be computed completely independent of all others, all you need to do is define this. Make sure you have like UV input, you have a color output, and this whole thing can become your own custom procedural texture, where you just decide, based on the coordinate you're in, you're gonna do whatever you want to compute pixel color, and it's just gonna compute it for you. And with this, it'll also fit in a way that, like, this can be done in a multi-threaded manner, because each pixel is independent, so like the code that's actually generating the texture can call this node, you know, in parallel. So this is going to be like more complicated ones, you know, like you'll be able to do ones, you know, to do your own custom procedural meshes, for example, where that one's going to be probably a little bit more complicated, because you'll have to, like, you know, kind of build the geometry. But essentially, the way that one might work is, you know, you get an impulse, and then, like, you do whatever logic you want to do, build a mesh, and, like, you're done, and now you have your, you know, procedural mesh component, and you can just use it like any other procedural component. So I think once this kind of goes in, this is going to be a particularly powerful mechanism that a lot of, like, systems that are even don't have much to do with Protoflux right now, they will strongly benefit from it. So this to me is going to be, like, you know, a really big feature of, like, Protoflux. The other one that I'm particularly looking forward to, especially implementing it and playing with it, is the DSP mechanism. And what that will let you do is make sort of workflows with the nodes, you know, to do stuff like processing audio, processing textures, and processing meshes. With those, you'll be able to do stuff like build your own, you know, like audio studio or music studio, where you can, you know, do one of those like filters, you know, on audio. You can have signal generators, and you could pretty much use Resonite, you know, to produce music or produce sound effects, or you could use it to make, you know, interactive audio visual experience, where, like, there's like a lot of kind of, you know, real-time processing to audio, and you can feed it, like, you know, what's happening in the world, and kind of, you know, change those effects. And that on itself will open up a lot of, like, new kind of, you know, workflows and options that are not, you know, available right now, or they're kind of like, they're a little bit there, but, you know, not quite, not enough for people to like really even like realize it. So the DSP, that's a big one. Same like, you know, with the texture one, like you'll be able to do procedural textures, which on itself is also like, you know, really fun to play with. But also you can now, once we have those, you'll be able to use Resonite as a production tool. You know, even like say, like if you're building a game in Unity or Unreal, you could use Resonite as part of your workflow to produce some of the materials for that game. And it gets a lot of the benefits, you know, of having it be like, you know, a social sandbox platform. Because say you're working, you know, on a sound effect, or working on music, or working on procedural texture, you can invite people in and you can collaborate in real time. That's given, you know, thanks to Resonance architecture. It's just automatic. If you have like, you know, like for your favorite setup, you know, for like studio, for working on something, you can just save it into your inventory, send it to somebody, or just load it, or we can publish it and let other people, you know, play with your studio setup. So the DSP part is also, I think, gonna be a big sort of like a doorway to like, you know, lots of new workflows and lots of new ways to like use Resonite. So I'm really excited, you know, for that part. And also like part of it is like I just love, you know, audio-visual stuff. Like you wire a few nodes, you know, and now you have like some cool visuals coming out of it, or some cool audio, you know, and you can mess with it. There's another part for the mesh processing, because you could, for example, have there could be like a node where you input a mesh, and on the output you get like a subsurface, like subdivided, smoothed out mesh. Or you do like, you know, maybe it voxelizes it, maybe it triangulates, maybe it applies, you know, Boolean filter, or, you know, maybe there's some perturbation to the surface. And that feature, I think, will combine with yet another feature that's on the roadmap, which is like vertex-based mesh editing. Because you'd essentially be able to do a thing where, you know, say like you have like a simple mesh, and like this is what you're editing, and then like this mesh, you know, this live mesh, I'm actually gonna delete this one in the background because they're a bit bad for the contrast. So I'm taking also a little bit like for this question, but this is one I'm particularly excited for, so I want to go a little bit like in depth on this. Okay, that should be better. So you're editing this mesh, and then you have like, you know, your own node setup that's, you know, doing whatever processing, and, you know, it's making like a more complex shape out of it because it's applying a bunch of stuff. And you edit like one of the vertex, and it just runs through the pipeline, you know, your mesh DSP processing pipeline, and computes new output meshed based on this as an input. So like you move this vertex, and this one, you know, maybe it does, you know, like this kind of thing. You do this kind of like modeling. If you're used to Blender, this is what you do with the modifiers, where like, you know, we can have simple base geometry and have like, you know, subdivision surface, and they're like moving vertices around, and it's updating the more complex mesh by processing with the modifiers. The mesh DSP combined with the vertex editing will allow for a very similar workflow, but one that I feel is even more powerful and flexible, and also will probably be a lot more performant because our, you know, processing pipeline is very asynchronous. Because one of the things, like when I like mess with Blender, one of the things that kind of bugs me is like, you know, if you use modifier that like takes a lot of processing, the whole interface essentially lags. The way stuff is written in Resonite is like, you will not lag as a whole, but only the thing that's updating will maybe take like, you know, say this takes a second to update and I move the vertex, I'll see the result in a second, but I will not lag entirely for a second. So that itself, I think, will like, you know, combine really well with lots of, you know, upcoming features and also lots of existing features. And for me, that's just big, you know, big part. Even just beyond Protoflux, it's how I like to design things. This way where each system is very general. It does its, you know, own thing, but also it has like lots of ways to interact with lots of other systems, because that way you get all these kind of emergent workflows that become like, very powerful, and you get lots of ways to combine those systems, into like a single pipeline. So that should kind of cover it. I'm gonna hop back here. I went a little deep like on this particular question, but hopefully that kind of shed some idea on like some of the kind of future things and things I want to do, with not with just Protoflux, but with other things. There we go. Sorry, I'm just settling back in. So I hope that answers the question like in a good detail. So next question we have, Troyborg is asking, you said you had a side project you wanted to work on when you get done with particle system before starting audio system rework. Are you able to talk about it? Yes, so the thing I was kind of thinking about is essentially I've been playing a lot with Gaussian splatting recently, and I can show you, some of the videos. Let me bring some of my splats. So right now, the only way I can actually show you these is, through a video. So this is one I did very recently. So this is probably one of the best scans. You can see if I play this, I'm like, I almost asked you like, is this loaded for you? But like, it only needs to be loaded for me. But if you look at this is a scan of a fursuit head of like a friend who's here like in Czech Republic. His name is Amju. He let me scan like his fursuit head, and I first reconstructed with the traditional technique, but then I started playing with Gaussian splat software. I threw the same data set at it, and like the result is incredible. Like if you look at the details of the fur, like the technique is capable, of capturing the, the softness of it. Like it just, like, it just looks real. Like that's the easiest way to describe it, is like it gives you incredible amount of detail while still being able to render this at like, interactive frame rates. And I really like I've been like 3D scanning for like years. Like, I love like 3D scanning stuff and making like models of things. And this technique, it offers a way to reconstruct, things. I can actually, hold on, let me also bring one more. This, I can show you how the result of this looks with traditional photogrammetry. So if I bring this, you see this is traditional mesh, and it's a pretty good result. Like I was like really happy with this. But like if you look, there's like no softness in the hair. There's like artifacts around the fur. It gets kind of like, blobbish. It's like it loses its softness that the Gaussian splats are able to preserve. This is another kind of example. I took these photos for this like in 2016. Like that's like, I think for like 8 years ago now. And it's just like, also like if you just look at the part, it just looks real. Like I'm really like impressed like with the technique. I've been like kind of having a lot of fun with it. And I've been kind of like, like on my off time, I've been kind of like I've been essentially like looking for ways I kind of like looking at how it like works. And the way the Gaussian splats like work, it's relatively simple in principle. Like it's like an extension of point cloud, where instead of like, just tiny points, each of the points can be like, a colorful blob that's like has like fuzzy edges to it, and they can have different sizes. Some of them, you can actually see some of the individual splats. Some of them are like long and stretched, some of them can be round, some are small, some are big, and they can also change color based on which direction you're looking at them from. So I've been essentially looking for a way, can we integrate Gaussian splatting rendering into Resonite? And I'm fairly confident like I'll be able to do it at this point. Like I understand it like well enough to make an implementation. The only problem is, I don't really have time to actually commit to it right now because I've been focusing on finishing the particle system. But the thing I wanted to do is, after I'm done with the particle system, mix in a smaller project that's more personal and fun, just sort of like like a mental health break, pretty much. It's something, just kind of do this primarily for myself, because I want to bring those scans in and showcase them to people. I'm still not 100% decided. I'll kind of see how things go, but I'm kind of itching to do this and doing a little bits of research, like in like on the weekends and so on to get this going. So it's something I like to do. I think so, also something that like a lot of people would appreciate as well, because I know there's other people in the community who were playing with splats and they wanted to bring them in, and I think it would also make Resonite kind of interesting to a lot of people who might not even think about it now, because it's essentially going to give you ability to visualize the Gaussian splats in a collaborative sandbox environment. So it might even open up some new doors, but I'm not 100% decided, but pretty much this is kind of what I've been kind of thinking about. Next, Noel64 is asking, hi, are there plans to add instant cut options for cameras? The current fly from one place to another seeking looks a bit weird video over longer distances. You can already do this, so there's an option, I just have it at default, which does have the have the fly, but there's literally a checkbox in my UI, interpolate between anchors. If I uncheck that, and I click on another, this is instant, and I will click over there if I can oh no, there's a collider in the way. I'm just gonna do this. I click on it, I'm instantly here. So that feature already exists. If it kind of helps, I can just, keep this one on, so it doesn't do the weird fly through. But yes, I hope that answers the question. Next, Wicker Dice, what would you like Resonite to be in 5 years? Is there a specific goal or vision? So for me, the general idea of Resonite is, it's kind of hard to put in words sometimes, because in a way that would be a good way to communicate, but it's almost it's like a layer. It's like a layer where you have certain guarantees. You're guaranteed that everything is real-time synced. Everything is real-time collaborative. Everything is real-time, editable. You have integrations with different hardware. You have, persistence. You can save anything, whether it's locally or through cloud, but everything can be persisted. And what I really want Resonite to be is be this layer for lots of different workflows and for lots of different applications. And the most clear one is, social VR, where just, you hang out with friends, you're watching videos together, you're playing games together, you're just, chatting or doing whatever you want to do. But if you think about it, all of it is possible thanks to this, baseline layer. But there's also other things you can do which also benefit from the social effect, and it kind of ties into what I've been talking about earlier, which has to do with using Resonite, as a work tool, as part of your pipeline. Because if you wanna be, working on music, if you want to be more, making art, if you wanna be doing some designing and planning, you still benefit, from all these aspects of the software. Being able to collaborate in real time, being able to if I'm working on something and showing something, you immediately see, the results of it. And you can mess with it, modify it, and you can build your own applications on it. People, given Resonite's nature, you can build your own tools and then, share those tools with other people as well, if you want to. So for me, what I would really want Resonite to be is sort of a foundation for lots of different applications that goes just, beyond just social VR, but which enriches pretty much whatever task you want to imagine, with that social VR, with the real-time collaboration and persistence and networking, that kind of aspect. think of it as, something like Unity or your own Unreal, because those engines, or Godot, I shouldn't forget that one. These engines, they're maybe primarily, designed for building games, but people do lots of different stuff with them. They build like, scientific visualization applications, medical training applications. Like some people build actual just, utilities with them. And they're very general tools which solve some problems for you. So you don't have to worry about, low-level graphics programming in a lot of cases. You don't have to worry about, having basic kind of functional engine. You kind of, you kind of get those like, for free, in quotes. Like in a sense, you don't need to spend time on them. That's already provided for you. And you can focus more on what your actual application is, whether it's a game, whether it's a tool, whether it's, research application, whatever you want to build. I want Resonite to do the same, but go a level further, where instead of like, just providing the engine, you get all the things I mentioned earlier. You get real-time collaboration. Whatever you build, it supports real-time collaboration. It supports persistence. You can save it. We already have integrations, with lots of different hardware. Like interactions, like grabbing things. Like that's just given. You don't have to worry about that. You can build your applications around that. So I want Resonite to be sort of like, like almost the next level, beyond game engines. And another kind of analogy I use for this is, if you look at early computing, like, when computers were like, big and room scaled, the way they had to be programmed is, with like, punch card, for example. I don't know if that was like the very first method, but it's one of the earliest. And it's very difficult because you have to like, you have to write your program, and you have to translate it into individual like, numbers on the punch card. And then, later on there came assembly programming languages. And those made it easier. They let you do more in less time, but it was still like, you have to, think about managing your memory, managing your stack. You need to decompose, complex like task into these like, primitive instructions, and it still takes a lot of mental effort. And then later on came, a higher level programming languages, like, I'm kind of skipping a lot, but like, say C, C++, Java, C#. And you get even languages like Python. And they like added further abstractions where, for example, if it's, modern C and C++, you don't have to like worry about memory management as much, at least not, managing your stack. And now, like, now some of the things you had to worry about, they're automatically managed. Like, you don't even have to think about them. You can just focus, my function accepts these values, outputs this value, and it like, generates the appropriate, stack management code and for you. And then, came like tools built with those languages, like I mentioned, Unity or Unreal, where you don't have to worry about, or Godot, where you don't have to worry about, having the game engine, like, being able to render stuff on screen. That's already provided with you. And with Resonite, the goal is to essentially move even further along, this kind of progression, to make it where you don't have to worry about the networking aspect, the persistence aspect, integrations with hardware. You're just kind of like, given that, and you can focus more of your time on what you actually want to build in that kind of environment. So that's pretty much, that's the big kind of like vision I have like on my end for what I want Resonite to be. Epic Easton is asking, what are your thoughts on putting arrows on generic type wires? I'm not actually sure if I fully understand that one. I don't know what you mean, like generic type wires. Like, do you mean like wires that are of the type? I probably need like a clarification for this one. Yeah, sorry, I can. I don't know like how to interpret the particular question, so I'll. Oh, he's asking arrows and wires. Some of them kind of have arrows. I mean, I think so. Like the impulse ones actually have arrows. I'm not really sure. Like, I'd probably need to like see an image or something. Next, Sid is asking, So like boxes of code that take inputs and give outputs, allowing for coding interface with Flux without having to build some parts of the function using the nodes. Yes. Yeah, pretty much like you can, your Protoflux node becomes a function that you can then other systems can call without even needing to know it's Protoflux. They're just like, they're just like, I'm gonna give you these values and I expect this value, as the output. And if your node, matches that pattern, then you can use it, give it to those other systems. Next question, Triborg, that does sound amazing. Is that something for after source custom Protoflux nodes? So it's not related to source. That's fully Froox engine side. So technically, it doesn't matter whether it happens before or source. It's not dependent on it in any way. There's part that is, which is having custom shader support, which you do want to do with Protoflux. That one does require, switch to source, because with Unity, the options to do custom shaders are very limited and very kind of hacky. So that one will probably wait, but for the parts I was talking about earlier, those will happen, regardless of when source comes in. Like it might happen after source comes in, it might happen before it comes in, but it's just purely, how the timing ends up working out and how the prioritization ends up working out. Next question, Shadow X. I'm just checking time. Shadow X with nested nodes. Will custom nodes be able to auto-update when source template for script node is changed? Yes, they will. There's like multiple ways to interpret this as well. But if you have a template and you have it used in lots of places, if you change the internals of that node, every single instance is going to be reflected. So you can actually, have it used in lots of objects in the scene, and you need to change something about its internals, everything's going to be reflected in the scene. The other interpretation is, if you make a library of nodes and say, you reference that, in your world, and the author of the library publishes an updated version, is that going to auto-update, other worlds, which do use that library? That would be handled by the molecule system, which is, our planned system for sort of versioning. And we want to use it not just for Resonite itself, but also for Protoflux. So you can, publish, your library functions and so on. And with that, what we would do is let you define, rules on when to auto-update and when not. We probably follow something, like semantic versioning. So if it's minor update, it auto-updates unless you unless you disable that as well. If it's a major update, it's not going to auto-update unless you specifically ask it to. So that's going to be that's the other part of it. That one's definitely going to this one going to give you more of a choice. Next question, Troyborg. So could you have something like bubble node that has all the code for them floating around randomly, the random lifetime on it? I'm not fully sure what you mean bubble node, but yeah, pretty much you can package, all the code, for whatever you want the bubble to do is in that node, and it doesn't need to be, if you mean, for example, my bubbles, oh, that didn't work. There we go, like this one. You see, I have this bubble, and this bubble, it has code on it that handles, it handles it flying around. And right now, when I make the bubble, it actually duplicates all the code with the bubble, which means the Protoflux VM needs to compile all that code. It's relatively simple, so it's not as much, but still, it adds up. Especially if you have if you had hundreds of these or thousands. With the nested nodes, all this bubble will need to do is, just reference that template and only need one of it, which means it's just going to reuse the same, compiled instance of the particle node instead of duplicating literally the entire thing on each of the objects you make independently. So next, question from Toyborg, for processing textures, you could do stuff like level, curves adjustments. Like in Blender Classroom, the texture for albedo, they adjusted with levels and grayscale and plug into height map instead of separate texture. Yeah, you could. I mean, I kind of don't fully understand like how to map this question to Resonite, but because I'm not familiar with Blender Classroom, but you could, define your own procedural texture and then, use it in other stuff. That procedural texture, it will end up as actual bitmap. It's gonna, it's gonna run your code to generate the texture data, upload it to the GPU, and at that point, it's just a normal texture. But you're able to do stuff like that, or at least like, similar. Next question, does the sprinkles? I'm also just checking how many. There's a fair bit of questions. Does the sprinkles is asking, when we get custom nodes, do you think we'll be able to create our own default node UI? I could see using audio DSP fully custom nodes to make those. So the custom UI for the Protoflux nodes, that's completely independent from custom nodes. Like it's something like, we could also offer, but it's pretty much like a completely separate feature, because the generation of the node is, it's technically outside of the main Protoflux itself. It's sort of like the UI to work, like interface with the Protoflux. We could add mechanisms, to be able to do custom nodes. There are some parts of that, like that I'm a little bit careful with, because usually you can have, hundreds or thousands of the nodes, and having that like customizable or having customizable system that can end up like, a performance concern, because the customization, it can, depending on how it's done, it can add a certain amount of overhead. But it's not something, we're completely close to. It's just like we're probably going to approach it more carefully. It's not going to come as part of custom nodes though, like those are independent. Blue Sire, Sire unfortunately late, but I don't know if I can bring on it easier because I already have the setup without, I'm sorry. J. Wyden is asking, internally, how prepared is the engine to take full advantage of modern net past JIT? There's been lots of things since framework, like spans, to avoid allocs and unsafe methods, think bitcasting, that can make things way, way, way faster. Are there areas where you use the new features in the headless client through preprocessor directives or something? So, we do use like a number of features that are sort of backported to older versions, like, like you mentioned spans. Using, stack allocations and so on. And we expect those, to get like a performance uplift with modern runtime because those are specifically optimized for it. So there's like parts of the engine, like especially anything newer, like we've been trying to like, use the more modern mechanisms where possible. There are bits where we cannot really use the mechanisms, or if we did, it would actually be detrimental right now. There's like certain things like for example, vectors library. That one with modern net, it runs way faster, but if we used it right now, we would actually run way slower because with Unity's mono, it doesn't run well. Like there's certain things which if we did right now, like we'd essentially end up hurting performance until we make the switch. So we tend to like use a different approach that's not as optimal for the more modern net, but is more optimal now. So there might be like, some places like in code you can see like that, but where possible we try to use the modern mechanisms. There's also some things which we cannot use just because they don't exist, with the version of net, and there's like no way to backport them. Like for example, using, SMI the intrinsics, to accelerate a lot of the math. That's just not supported on the older versions, and there's no way, to like backport it, so we cannot really use those mechanisms. So once we do make the switch, like we expect like pretty substantial performance improvement, but part of like why we want to do the switch, especially as one of the first tasks, towards like performance, is because it'll let us use all the mechanisms, going forward. So when we build new systems, we can, take full advantage of, all the mechanisms that modern net offers. And we can over time also like, upgrade the old ones to get even more performance out of it. So like overall, I kind of expect, big performance, even for the parts that are not like most prepared for it, just because the code generation quality is way higher. But it's like we can essentially like, you know, like take then time, like, you know, to like get even more performance by switching some of the approaches to more performant ones. So by making the switch, then on itself is gonna, you know, big performance boost, but that's not the end of it. It also, you know, opens doors for doing even more, like following that. Next question, Zid, just Zid. Can those splats work within the engine? They aren't meshes, right? Could they be rigged? So splats, you can have to implement the support for yourself. The output isn't a mesh. Like the idea of Gaussian splatting is you're essentially using a different type of primitive, you know, to represent your, you know, I was gonna, I don't want to say mesh because, you know, it's not a mesh. Essentially represent your model, you know, your scene or whatever, you know, you're going to show. So instead of a triangle, you know, vertices and triangles that we have with traditional geometry, it's completely composed from Gaussians, which are a different type of primitive. You can actually use meshes to render those. From what I've looked, there's like multiple ways, you know, to do the rendering. One of the approaches for it is like, you know, you essentially encode like the splat data, and then you just render this. You use the typical, like, you know, GPU rasterization pipeline to render them as quads, you know, and then the shader does like the sampling of like spherical harmonics for like you know, so it can change color based on the like angle you look at it from and other stuff. There's other approaches that implement the actual rasterization in compute shader. And that can like lead to like more efficient ones. And at that point, like, you know, you're not using traditional geometry, but, you know, the approaches kind of vary. There's like lots of ways to like implement them. Next question, Troyborg. So is that something you need special software to create them, or is it just something in Resonite so it knows how to render that new format for 3D scan? We essentially need like a code to, like, you know, render them. The main, like the gist of it is the way you approach it is you get your data set, you know, your Gaussian splat. It's essentially a bunch of like, it's essentially points with lots of extra data. You have like, you know, the size of it, and then the color is encoded using something called spherical harmonics. And that's essentially like a mathematical way to like efficiently encode information on the surface of a sphere, which means like you can kind of sample it based on the direction. Like where, if you consider, you know, if you consider a sphere, I should have grabbed my brush. I'm gonna grab a new one because I'm too lazy to go over there. Brushes. Let's see. I'm not gonna like go over there because it's just a simple doodle. But say you have like, you know, this is sphere in, you know, 2D, it's a circle. And if it's like a unit sphere, then each point on the sphere is essentially a direction. So if you have information encoded, you know, on the surface of your sphere, then each point, like if I'm like, you know, if I'm the observer here, so this is, you know, my eye, and I'm looking at this, then the direction is essentially the point from the center of the sphere towards the observer. I use this direction to sample the function, and I get a unique color for this particle direction. If I look at it from this direction, you know, then I get this direction, and I sample the color here, and this color can be different than this color. And this is a way that the Gaussian splats, they were really good at encoding stuff like, you know, reflections, for example, because with reflection, you literally, the color on the point, like on the point, it literally changes based on the angle you look at it from. So, and it's the spherical harmonics that actually take the bulk of the data for Gaussian splat, because from what I've seen, they use a third order spherical harmonics, which means for each point you actually have 16 colors, which is quite a lot. And a lot of the work is like, you know, how do you compress that in a way that the GPU can decode like very fast on the fly, you know, so it doesn't eat all your VRAM. But yeah, essentially you write your code, you know, to answer the question more directly, you write your code, you know, to like encode it properly, and then like, you know, render it as efficiently as you can. And you can kind of utilize, you know, some of the existing like rasterization pipeline as well to kind of save you some time. Zijazid is asking, I don't have a good understanding of splats, but aren't they essentially particles? So I kind of like went over this a few times. Like they're not particles in the sense of particle system. There's like some overlap because each splat is a point, but it has a lot of additional data to it, and it's also not, you know, a tiny small particle, but like it can be like variously sized, you know, color blob. Next question, dusty sprinkles. So can you make splats with any 3D scans? I don't really get them, but they're neat. So the dataset I use for mine, it's essentially just photos. It's the same approach I use for traditional. Let me think. Like there's like different ways to like make them, but the most common one that I've seen is like, you know, you actually just take lots of photos, you use traditional approach, you know, the photos get aligned in a space, and like then you sort of like, you know, estimate like the depth, like the traditional, you know, 3D construction, except for the splats, it doesn't really estimate the depth. The way I've seen it done in the software I use is it starts with like a sparse point cloud that's made from the type points from the photos, essentially like points in space that are like shared between the photos, and it generates, you know, splats from those. And the way it kind of does it is, I believe it uses like gradient descent, which is a form of like machine learning, where each of the splats is actually taught how it should look so it matches your input images. So that's usually the longest part of the reconstruction process, because it has to like go through a lot of like, you know, training. And if you use the software I use, it's called Gaussian post shot. It essentially like, you know, it runs like usually like several dozen thousand like training steps, and you can usually in the beginning you can kind of see like the splats are very fuzzy and it's just kind of moving around, and they're sort of like settling into space and getting more detail, and it also like adds more splats, you know, in between them where it needs to add more detail. So there's like you know, whole kind of training process to it. I actually have a video I can show you, because there's also like a relevant question I can see. So I'm gonna because Shadow X is asking, does all common splatting software encode spherical harmonics? I never noticed color changes in my scans in a Scaniverse and PostShot. So I know for sure PostShot does it. I don't know about Scaniverse because I don't use that one. It's possible they simplify it, because like I've seen some implementations of Gaussian splats, they just throw away the spherical harmonics and encode a single color, which saves a ton of space, but you also lose, you know, one of the big benefits of them. But I can tell you, PostShot definitely does it, and I have a video that showcases that pretty well. So this is kind of Figment that I did for Fur, and I like reprocessed this with Gaussian splatting, and watch like, you know, the reflections on, you know, on the surface of the statue. You can see how they change based on where I'm looking from. It's kind of subtle. If I look at the top, there's actually another interesting thing, and I have another video for this. But Gaussian splatting is very useful if you have like good coverage from like all possible angles, because the way the scanning process works, like I mentioned earlier, they are trained to reproduce your input images as close as possible, which means for all the areas, you know, area where you have photo coverage from, they look generally great. But if you like move too far away from them, like in this case, for example, from the top, I was not able to take any pictures, you know, from the top of it. It actually kind of like, they start going a bit funky. Do you see like how it's kind of like all kind of fuzzy and the color is blotchy? And that's kind of like, for one, it shows, you know, like it does encode, you know, the color based on the direction, but it also shows like one of the downsides of it, because I have another video here. So this is a scan of, this is like, I don't even know how long ago, this was like over 6 years ago, when like my family from Ukraine, they were like visiting over because my grandma, she was Ukrainian, and they made borscht, which is like another kind of traditional kind of like foods. And I wanted to scan it, but I literally didn't have time because they put it on the desk. I was like, I'm gonna scan it, and I was only able to take 3 photos before they started moving things around. But it actually made for an interesting scan because I was like, how much can I get out of 3 photos? And in the first part, this is traditional scan with a mesh surface that's done with, with Agiso meta shape. Oh, I already switched to the other one. So you see all the reflections, they're kind of like, baked in. It doesn't actually look like metal anymore. There's, lots of parts missing because literally they were not scanned, but the software was able to estimate the surface. It knows this is a straight surface. If I look at it from the angle, apart from the missing parts, it's still coherent. It still holds shape. With Gaussian splatting, it doesn't necessarily reconstruct the actual shape. It's just trying to look correct from angles, and you'll be able to see that in a moment. So this is the Gaussian splat, and you see it looks correct, and the moment I move it, it just disintegrates. Like, you see it's just a jumble of, colorful points, and it's because all the views that I had, they're like relatively close to each other, and for those views, it looks correct because it was trying to look correct, but because there's no cameras, from the other angles, the Gaussians are free to do, just whatever. Like they don't have anything to constrain them, to look particle away, so it just ends up a jumble. And that's a very to me, that's very kind of interesting way to visualize the differences between the scanning techniques. But yeah, that's kind of long-winded answer to it. Yes, they do encode the spherical harmonics. And you can make it pretty much with any scans, but the quality of the scan is gonna depend, on your data set. And I'll be kind of throwing, because I have terabytes of 3D scans, I'll be just throwing everything, at the software and seeing what it ends up producing. I know there's also other ways. There's some software, also just double checking time. There's also, some software that just generates it with AI and stuff, but I don't know super much about that. So there's other ways to do them. But I'm mostly familiar with the one, I'm mostly familiar with, using photos as a data set. Next question. J. Wyden 4. Protoflux is a VM. It compiles things. So technically VM and compiling, those are 2 separate things. Also, Epic Easton is asking what is a Protoflux VM, so I'm gonna just combine those questions into one. So yes, it is a VM, which essentially means it's sort of it has a defined sort of runtime. It's a technically stack-based VM. It's how do I put it? It's essentially sort of an environment where the code of the nodes, it knows how to work with the particle environment that sort of isolates it, from everything else. It's sort of it's like a runtime that's able to run the code. It sort of compiles things. It's sort of a halfway step. It doesn't directly produce machine code from actual code. The actual code, of the individual nodes that ends up being machine node for the node itself, but the way it can operate with the VM, what Protoflux does, it builds something called execution lists and evaluation lists. So if you have a sequence of nodes or sequence of impulses, it's going to look at that and be like, okay, this executes, then this executes, then this executes, and builds a list. And then during execution, it already has that pre-built list, as well as it resolves things stack allocation. It's okay, this node needs to use this variable, and this node needs to use this variable. I'm going to allocate this space on the stack, and and I'm going to give these nodes the corresponding offsets so they can read the proper values to and from the stack. So it kind of it does a lot of the building process. It doesn't end up as full machine code, so I would say it's sort of a halfway step towards compilation. Eventually we might consider doing sort of a JIT compilation where it actually makes full machine code for the whole thing, which could help improve the performance of it as well. But right now it is a VM that with a sort of halfway compilation step to kind of speed things up. It also does it to validate certain things. For example, if you have infinite kind of continuation loops, certain things are essentially like illegal, like you cannot have those be a valid program, which kind of helps avoid, some, everyone's like, having some kind of issues where we have to figure out certain problems at the runtime. But in short, like the Protoflux VM, it's like a way for, the Protoflux to essentially do its job. It's like an environment, execution environment, that defines how it kind of works, and then all the nodes can operate within that environment. Next question, Nitra is asking, is the current plan to move the graphical client to Net9 via multi-process architecture before move to SOS? Yes. So we are currently, I'm actually I've done it on the first one, but since I have a little bit better setup, I might do it again just to get like, a better view. Let me actually get up for this one. I'm gonna move over here. There we go. So I'm gonna move over here. I already have my brush that I forgot earlier. I'm gonna clean up all this stuff. Let's move this to give you like a gist of like the performance update. There we go. Clean all this up. Make sure I'm not gonna hit a wall. Grab my brush. There we go. So right now, a little bit more. Right now, so the way like the situation is right now. Oops. So imagine this is Unity. I'm actually gonna write it here. Unity. And this is within the Unity, we have Froox engine. So this is Froox engine. I'm just gonna type Froox and so Unity, it has its own stuff. Just like whatever Unity has. And then with Froox engine, most things in Froox engine, they're actually fully contained, within Froox engine. So there's like lots of systems, just gonna draw them as little boxes. And they're kind of like, fully contained. Unity has no idea that they even exist. But then right now there's two systems, which are sort of shared between the two. There's a particle system, and then there's the audio system. So those two systems, they're essentially a hybrid, where Froox engine does some work and Unity does some work, and they're very kind of intertwined. There's another part when Froox engine communicates with Unity. There's another bits. There's also like lots of like little kind of connections between things that kind of tie the two together. And the problem is Unity uses something called Mono, which is a runtime. It's also actually like a VM, like the Protoflux VM, but different. But essentially it's responsible for taking our code and running it, translating into instructions for your CPU, providing, all the like kind of base library, like, implementations and so on. And the problem is the version that Unity uses, it's very old and it's very slow. And because like all of the Froox engine is kind of running inside of it, that makes it, that makes all of this like slow as well. So what the plan is, in order, to get a big performance update, is first we need to like simplify, we need to disentangle the few bits of Froox engine from Unity as much as possible. The part I've been working on, is the particle system. That one's very close. I think we'll probably start this thing next week. It's called Photon Dust. That's our new in-house particle system. And the reason we're doing it is so we can actually, take this whole bit. Oh no. I might just redraw it. I wanted to make a nice visual part, but it's not cooperating. I'm just gonna do this. And then I'll do this. And just, particle system, audio system. So what we do we essentially replace this with this. We make it fully contained inside of Froox engine. Once that is done, we're going to do the same for the audio engine. So it's going to be also fully contained here, which means we don't have, ties here. And then this part, instead of lots of little kind of wires, we're going to rework this. So all the communication with Unity happens via a very nicely defined sort of package, where it sends the data, and then the system, it'll do whatever here. But the tie to Unity is now, greatly simplified. It essentially sends all the stuff, that needs to be rendered, and some stuff that kind of needs to come back is sent over a very well-defined interface that can be communicated over, some kind of inter-process communication mechanism. Probably combination of a shared memory and some pipe mechanism. Once this is done, what we'll be able to do, we could actually take Froox engine and take this whole thing out. If I can't even grab the whole thing, it's being unwieldy. Just pretend this is smoother than it is. They'll take it out into its own process. And because we now control that process, instead of, having been abandoned with Unity, we can use net9. And this part, this is majority of, where time is spent running, except, when it comes to rendering, which is Unity part. Which means, because we'll be able to run with net9, we'll get a huge performance boost. And the way we know we're gonna get significant performance boost is because we've already done this for our headless client. That was the first part, of this performance work, is move the headless client to use .NET 8, which now is .NET 9 because they released a new version. The reason we wanted to do headless first is because headless already exists outside of Unity. It's not tied to it. So it was much easier to do this for headless, than doing this for a graphical client. And headless, it pretty much shares most of this. Most of the code that's doing the heavy processing is in the headless, same as, on the graphical client. When we made the switch and we had the community start hosting events with the .NET 8 headless, we noticed a huge performance boost. There's been sessions, for example, the Grand Oasis karaoke. I remember their headless used to struggle when it was getting around 25 people, and the FPS of the headless would be dropping down, the session would be degrading. With the .NET 8, they've been able to host session which had, I think at the peak, 44 users, and all the users, all of their IK, things that all the dynamic bolts, all the, Protoflux, everything, that's being computed on graphical client, it was being computed on headless, minus obviously, rendering stuff. And the headless was able to maintain 60 frames per second with 44 users, which, that's at least an order of magnitude kind of improvement over, running with mono. So doing it for headless first, that sort of let us, gauge how much of a performance improvement will the switch make, and whether it's worth it, do the separation as early as possible. And based on the data, it's pretty much I feel like it's very, very worth it. And that's why we've been kind of, focusing on making this happen, making, this pull, do this kind of thing where you can pull Froox engine out of Unity, run it with .NET 9, and then the communication, we'll just do, instead of the communication happening within the process, it's gonna pretty much happen the same way, except across, process boundary. The other benefit of this is, how do we align this, because we still, even when we do this, once we reach this point, we'll still want to get rid of Unity for a number of reasons. One of those is, being custom shaders. Those are really, really difficult to do with Unity, at least, making them real time and making them, support backwards compatibility, making sure the content doesn't break, stuff like that. Being able to use more efficient rendering methods, instead of, having to rely on deferred, we'll be able to like, use like cluster forward, which can handle, lots of different shaders with lots of light. So we'll want to get rid of Unity as well. And this whole thing where the communication between Froox engine, which does, all the kind of computations and then sends stuff, be like, please render this stuff for me. Because this process makes this a lot more defined, we can essentially take the whole Unity, just kind of yeet it away. And then we'll plug in source instead. So source is going to have like, its own things. And inside like source is actually going to be like, right now it's being built on the Bevy, like rendering engine. So I'm just going to put it there. And the communication is going to happen pretty much the same way. And this is going to do whatever. So we can snip Unity out and replace it with source. There's probably going to be some minor modifications to this, how it kind of communicates, so we can kind of build around the new features of source and so on. But the principle of it, by moving Froox engine out, by making everything neatly combined, making a neat, communication method, it makes the switch to source much easier as well as the next step. It's actually the latest thing from development of source. There was actually a decision made that source is probably not going to have any C# parts at all. It's going to be purely Rust based, which means like it doesn't even need to, worry about net9 or like, C# interop, because its responsibility is going to be, rendering whatever Froox engine sends it. And then maybe, sending some like call like methods kind of back, like where it needs to be bidirectional communication to like, sync stuff up. But all the like, actual word, like the word model, all the kind of like, all the like, interaction that's going to be fully contained in Froox engine external to source. Then on itself, that's going to be a big upgrade, because it's going to be much more modern rendering engine. We'll be able to do, things like the custom shaders, like I was mentioning. There's some potential benefits to this as well, because it the multiprocess architecture, it's inspired by, Chrome and Firefox, which do the same thing, where your web browser is actually running, multiple processes. One of the benefits that adds is, sandboxing, because once this is kind of done, we'll probably do the big move like this. And at some point later in the future, we'll split this even into more processes. So each of the worlds you host, can be its own process, also net9, or whatever the net version is. So this can be like, one world, this can be another world, and these will, communicate with this, and this will communicate with this. And the benefit is like, if a world crashes, it's not going to bring the entire thing down. It's the same thing, in a web browser. If you ever had your browser tab crash, this is kind of similar principle. It crashes just the tab instead of crashing the whole thing. Similar thing, we might be able to, I'm not promising this right now, but we might be able to design this in a way where if the renderer crashes, we'll just relaunch it. You'll still stay in the world that you're in. Your visuals are just gonna, go away for a bit and then gonna come back. So we can like, reboot this whole part without bringing this whole thing down. And of course, if this part comes down, then it's over. But then you have to restart. But by splitting into more modules, you kind of, you essentially eliminate the possibility of crashing, because this part will eventually be doing relatively little. It's just going to be, coordinating the different processes. But for the first part, we're just going to move, Froox engine into a separate process out of Unity. That's going to give us big benefit thanks to net9. There's also other benefits because, for example, Unity's garbage collector is very slow and very CPU heavy. With net9, it has way more performant one as well. We'll be able to utilize, new performance benefits of like net9, like in the code itself, because we'll be able to start, using new functions within Froox engine. Because now it like, now we don't have to worry about what Unity supports. Following that, the next big step is probably going to be switch to source. So we're going to, replace Unity with source. And at some point in the future, we'll do like more splitting, for Froox engine into more separate processes to improve stability. And also add sandboxing, because once you kind of do this, you can sandbox this whole process using, the operating system sandboxing primitives, which will improve security. So that's kind of like, the general kind of overall plan, what we want to do, with the architecture of the whole system. And it's been like heavily, like, I've been like reading a lot, how Chrome and Firefox did it. And Firefox actually did a similar thing where they used to be like a monolithic process. And then they started like, doing work to break it down into less processes. And eventually did, just 2 processes, and then they kind of broke it down into even more. And we're essentially going to be doing similar thing there. So I hope this kind of answers it, gives you a better idea of what we want to do with performance, for Resonite, and what are the major steps that we need to take, and also explains why we are actually reworking, the particle system and audio system. Because on the surface, it might seem, there's like, why we're reworking the particle and audio system when we want, more performance. And the reason is, just so we can kind of shove them fully into Froox engine, make them kind of mostly independent, like, of Unity, and then we can pull the Froox engine out. And that's the major reason we're doing it. The other part is, so we have our own system that we kind of control. Because once we also switch Unity for Source, if the particle system was still in Unity, Source would have to re-implement it, and it would also complicate this whole part. Because like, now we have to like synchronize this particle system with all the details of the particle system on this end. So that's another benefit. But there's also some actual performance benefit even just from the new particle system. Because the new particle system is designed to be asynchronous, which means if you do something really heavy, you're only gonna see the particle system lag, and you will not lag as much, because the particle system, if it doesn't finish its computations within a specific time, it's just gonna skip and render the previous state, and the particle system itself will lag, but you will not lag as much. So that should help improve your overall frame rate as well. So that's pretty much the gist of it. The particle system is almost done. We'll probably start testing like this upcoming week. The audio system, that's going to be the next thing. After that is going to be the interface with Unity. Once that is done, then the pull happens into the separate process, which is going to be a relatively simple process at that point, because everything will be in place, for that pull out from Unity to happen. So hopefully this kind of gives you a much better idea. And if you have like any questions about it, feel free to ask. We're always happy to kind of clarify how this is going to work. I'm gonna go big. Boink. There we go. I'm gonna sit down. There we go. So there was another of those kind of rabbit hole questions. I kind of did this explanation on my first episode, but I kind of wanted to do it because I have like a little bit better setup, with the right things, so we can make also like a clip out of it, so we have something to refer people to. But yeah, that's the answer to Nitra's question. I'm also checking time. I have like about 30 minutes left. So let's see. There's a few questions, but I think I can get through them. It's actually kind of working out. I've been like worried a little bit because I'm taking a while to answer some of the questions and going on tangents, but it seems to kind of work out with the questions we have. So next, Shadow X. Does all common splatting software encode... Oh, I already asked. Sorry. I already answered that one. J. Wyden 4. So VM is kind of like optimization layer rather than something akin to CLR or Chrome V8. So it has the fundamentals of a VM, but goal is to just have Resonite know ahead of time what needs to be run pipeline quickly. It's the same general principle as like, as the CLR or Chrome's V8. VM is essentially... It's just an environment in which the code can exist and in which the code operates. And the way the VM, runs that code can differ. Some VMs, they can be purely interpreted. You literally, maybe you just have a switch statement that is just switching based on instruction and doing things. Maybe it does, some kind of like compose into some sort of AST and then, evaluates that. Or maybe it takes it and it actually emits, machine code for whatever architecture you're running on. There's lots of different ways for VM to execute your code. So the way Protoflux executes code and the way CLR or V8 executes code is different. I think actually V8, like, I think it does like a hybrid where it like, it kind of converts some parts into machine code and like some it kind of interprets, but it doesn't interpret the original, like, you know, typed code. It interprets like some of the, you know, abstract syntax tree. I don't fully remember like the details, but I think like V8 like does a hybrid where you can actually have kind of both. CLR, that, yeah, CLR I think always translates it to machine code, but one thing they did introduce with the latest like .NET versions is they have multi-tiered JIT compilation. So one of the things they do is like when your code runs, they will JIT compile it into machine code, which is actually, you know, native code for your CPU, and they just run it like they just compile it like, you know, fast, because you don't want to be waiting, you know, for the application to actually run, but that means they cannot do as many optimizations. What they do though is like when the JIT compiler makes that code that's like, you know, done in a very quick way, so it's not as optimal, it adds like a counter each time like, you know, method is called, and if it crosses a certain threshold, you know, say like the method gets called more than 30 times, it's gonna trigger the JIT compiler to compile a much more optimized version, where like it goes really heavy, you know, on the optimizations to make much more faster code, which is gonna take it some time. But also in the meanwhile, as long as it's doing it, it can still keep running, you know, the slow code that was already JIT compiled. Once the JIT compiler is ready, it just swaps it out for the more optimized version, you know, and at that point your code actually speeds up. So we have code that's like, you know, being called very often, you know, like the main game loop, for example, it ends up compiling it in a very optimal way. If you have something that runs just once, like for example some initialization method, you know, like when you start up the engine, there's some initialization that only runs once. It doesn't need to do heavy optimizations on it because that would just waste of time. It speeds up the startup time and kind of optimizes for both. And I think the latest version, it actually added, I forget the term for it they used, but it's essentially like, you know, multi-stage compilation where they look at what are the common, you know, arguments for a particular method, and then assume those arguments are constants, and they will compile a special version of the method, you know, with those arguments as constants, which lets you optimize even more. Because now you don't have to worry, can this argument, you know, be different values, and you have to do all the math. It can pre-compute all that math that is dependent on that argument ahead of time, so it actually runs much faster. And if we have a method that is oftentimes called with very specific arguments, it now runs much faster. And there's actually another VM that did this called the Lua JIT, which is like runtime for the Lua language. And what was really cool about that one is like, even though Lua, you know, it's just considered this kind of scripting language, Lua JIT, it was able to outperform languages like C and C++ in some benchmarks. Because with C and C++, all of the code is compiled ahead of time. So like you don't know actually, you know, what kind of arguments you're getting. What Lua JIT was able to do is like be like, okay, this value is always an integer, or maybe this value is always integer that's, you know, number 42. So like I'm just gonna compile a method that assumes this is 42, and it makes like super optimal version of the, you know, method. And that when runs, like, you know, it's even more optimized, you know, than the C and C++, because C and C++ cannot make those assumptions. There's like some, like, you know, I know there exists like, you know, there's like profiling compilers where you actually run your code, and, you know, they will try to also figure it out, and then you compile your code, you know, with those kind of profiling optimizations, and can do some of that too. But it kind of shows, you know, like it like there's some benefits, you know, to the JIT compilers where they can be kind of more adaptive, and they can kind of, you know, do it for free, because you don't have to like you know, do it as a part of your development process. Once you kind of upgrade to the newer system, it just kind of, you get all these kind of benefits, and it's able to run your code, that's the same exact code as you had before, it's able to run it much faster because it's a lot smarter how it converts it into machine code. So next question is, Nitra is asking, how about video players? Are they already full inside Froox engine as well? No, for video players, they actually exist more on the Unity side, and they are pretty much going to remain majorly on the Unity side. The reason for that is because the video player, it has a very tight integration with the Unity engine because it needs to update, you know, the GPU textures with the decoded video data. It adds a bit like, you know, to the mechanism because we will need to send the audio data back for the Froox engine to like process and send back. So that's gonna be like video players are essentially gonna be considered like, you know, as an asset, because even like, you know, stuff like textures, when you load a texture, you know, it needs to be uploaded to the GPU memory, it needs to be sent to the renderer. And the way I plan to approach that one is, you know, through a mechanism called shared memory, where the texture data itself, Froox engine will allocate in a shared memory, and then it will pass, you know, over the pipe, it will essentially tell the renderer, here's shared memory, here's the texture, like, you know, information, like the size, format, and so on. Please upload it to the memory under, you know, this handle, for example. And it assigns it, you know, some kind of like number to identify the texture. And essentially sends that over to the, you know, Unity engine. Unity engine is gonna like, you know, read the texture data, run the upload to the GPU, and it's gonna send a message back to Froox engine, be like, you know, texture number, you know, 420 has been, you know, uploaded to the GPU, and Froox engine knows, okay, this one's now loaded. And then when it sends it, please render these things, it's gonna be like, okay, render this thing, you know, with texture number 422. And it's gonna, you know, send it as part of that package to like Unity, and Unity will know, okay, I have this texture and this number, you know, and like it's gonna like prepare things. It's gonna be similar thing with video players, where the playback and decoding happens on the Unity side. And Froox engine just sends, you know, some like basic information to kind of update it, you know, be like, you know, the position should be this and this, you know, like you should do this and this with the playback, and it's gonna be sending back, you know, some audio data. But yeah, those parts are gonna remain like within like Unity. It's not like quite a bit, like we have like 25 minutes, and there's only like one question right now. Che Viden, I guess something I don't really understand about Resonite is where simulation actually happens. The server simulate everything and the clients just pull, or the clients do some work and send to the server? It's a mix. For example, Polaris on IK, local Protoflux, or do all servers and clients simulate everything? Local as defined in Protoflux can get pretty confusing pretty fast. So usually it's a mix, but like the way like Resonite works, or like Froox engine works, is by default everything is built around your data model, and by default the data model is implicitly synchronized, which means if you change something in the data model, Froox engine will replicate it, you know, to everyone else. And the way, you know, most things like the components and stuff works is the data model itself, it's sort of like an authority on things, you know. It's like the data model says, you know, this is how things should be, and any state, you know, any state that's ends up, you know, representing something, like it represents, you know, something audiovisual, some state of some system that's fully contained within the data model, and that's the really important part. The only thing that can be like local to the components by default is, you know, any caching data, or any data, you know, that can be deterministically computed from the data model. So if the data model changes, it doesn't matter what internal data it has, the data model says, you know, things should be this way. And then like the whole synchronization is built on top of that. Like the whole idea is like, you know, by default, you don't actually have to think about it. Like, you know, like the data model is gonna handle the synchronization for you. It's gonna resolve conflicts. You know, it's gonna resolve, like, if, you know, say multiple people change a thing, or if people, like, you know, change a thing they're not allowed to, it's gonna, you know, resolve those data changes. And you essentially build your thing to like respond to data. So if your data is, you know, guaranteed to be synchronized and conflict resolved, then the behaviors that depend on the data always lead to the same, you know, or these convergent results. And what this does, it kind of gives you, benefits to write systems all over different ways. But like the main thing is like, you don't have to worry about synchronization. Like it just kind of happens automatically. And it kind of changes the problem where instead of like how do I put it? So instead of things being sync versus non-sync be a problem you have to think about, it turns it into an optimization problem. Because you could have, people like computing multiple kind of things, or like computing it on the wrong end, things that can be computed from other stuff, and you end up wasting network traffic as a result. But for me, that's much better problem to have than things getting out of sync. What we do have is like the data model has mechanisms to optimize that. One of those mechanisms being drives. Drives essentially tell, like, the drive is a way of telling the data model, I'm taking control, of this part of data model. Don't synchronize it. I am responsible for making sure, this stays, consistent when it needs to. And a way to think about drive is, you can have something like a smooth lerp node, which is, like one of the community favorites. And the way that works, it actually has like its own internal computation that's not synchronized. Whatever the input to smooth lerp is generally synchronized because it kind of comes from data model, but the output doesn't need to be synchronized because it's convergent. So like you're guaranteed to have the same value on the input for all users. You can fully compute the output value on each user locally because it's all converging towards the same value. And as a result, everybody ends up, with, if not the same, at least very similar, result on their end. It is also possible, you can, if you want to, diverge this data model. For example, value user override, it does this, where it has like, but it kind of does this in an interesting way because it makes the divergence values, it actually makes it part of the data model. So like the values that each user is supposed to get is still synchronized, and like everybody knows like this user should be getting this value, but the actual value that you derive with it, that's diverged for each user. And it's like a mechanism built on this principle, to handle this kind of scenario. You can also, like sometimes derive things from things that are going to be different on each user and have each user see a different thing. You can diverge it. The main point is, it's a deliberate choice. At least it should be in most cases, unless you do it by accident. But we'll try to make it harder to do it by accident. Because if you're like thinking I'm gonna specifically make this thing desync, it's like it's much less likely to happen by accident. Like either by bug or like misbehavior. The system's designed in a way to make sure that everybody shares the same general experience. So generally, like if you for example considered IK, like you mentioned like IK, like the actual computations, like of the bones, that's computed locally, and the reason for that is because the inputs to the IK is the data model itself, which is synchronized, and the real-time values are like hand positions. If you have tracking its feet positions, head position, those are synchronized. And because each user gets the same inputs to the IK on everybody's end ends up computing, the same or very similar result. Therefore, the actual IK itself doesn't need to be synchronized. Because, it's the final positions like they are driven. And essentially, that is a way of the IK saying, if you give me the same inputs, I'm going to produce, I'm going to drive these bone positions to match those inputs in a somewhat, mostly deterministic way. So that doesn't need to be. You also mentioned local Protoflux. With local Protoflux, there is actually a way for you to like hold some data that's outside of the data model. So locals and stores, they are not synchronized. If you drive something from those, it's gonna diverge unless you take the responsibility of computing that local in a way that's either convergent or like or deterministic. So locals and source, they're not gonna give you synchronous mechanism. One thing that's missing right now, what I want to do to prevent, divergence by accident, is have like a localness analysis. So if you have like a bunch of Protoflux and you try to drive something, and it's gonna check, is at the source of this value, is there anything that is local? And if it finds it, it's gonna give you a warning. You're trying to drive something from a local value, unless you make sure that value is, somehow, like, unless the results, of this computation stay synchronized, even if this value differs, or unless you make sure that the local value is, this computed the same for every user, or is very similar, this is gonna diverge. And that will make it, much more deliberate choice, where you're like, okay, like, I'm not doing this by accident, I really want to drive something from a local value, I'm taking the responsibility of making sure this will match for users. Or if you have a reason to, like, diverge things for each user, is a deliberate choice. You're saying, I want this part of the data model to be diverged. So I hope that kind of, like, answers the question. There's like a fair bit, like, I can do to this, but the gist of it, the local in Protoflux, like, it literally means, like, this is not part of the data model. This is not synchronized for you. This is a mechanism you use, to store data outside of the data model, and if you feed it back into the data model, you sort of need to kind of take, responsibility for making sure it's either, convergent or intentionally divergent. The other part is, this also applies if you drive something, because if you use the local and then you write the value and the value is not driven, the final value you write into the data model ends up implicitly synchronized and you don't have the problem. So this only applies if you're driving something as well. So I hope that kind of, like, helps understand this a fair bit better. There's about 14 minutes left. There's like one question. I'll see how long this kind of takes to answer, but at this point, I might not be able to answer, like, all the questions if more pop up. But feel free to ask them. I'll try to answer as many as possible until I get at the full 2 hours. So let's see. Ozzy is asking, you mentioned before wanting to do cascading as a dependencies after particles. Is this something you want to do? It is an optimization that's sort of, like, independent from the whole move, that I feel could be fast enough. I still haven't, like, decided, like, I'm kind of thinking about, like, slotting in before the audio as well, as part of the performance optimizations, because that one will help particularly with, like, memory usage, CPU usage, like, during loading things. For example, when people, like, load into the world and you get kind of, like, that loading, like, that kind of lag as the stuff loads in. The cascading as dependencies, they can particularly help with those cases when the users have a lot of stuff that's only visible to them, but, not to everyone else, because right now you will still load it. There's also, like, other parts, like if you have, like, words that are cold, or maybe the users are cold, you load all of them at once and it's just, this kind of big chunk. With this system, it will be kind of more spread out. The part I'm, like, not certain about, like, is whether it's worth doing this now or doing this after, like, make the net9 switch, because it is going to be beneficial on both. So it's one of those optimizations that's smaller and it's kind of independent, of the big move to net9, and it could provide benefit, even now, even before, we move to net9, and it will still provide benefit afterwards. So I'm not 100% decided on this one. I'll have to, like, evaluate it a little bit, and evaluate, how other things are kind of going. It's something I want to do, but no hard decision yet. Next, Climber is asking, could you use the red highlighting from broken Protoflux in a different color for local computation? I don't really understand the question, I'm sorry. Like, if Protoflux is, like, red and it's broken, like, you generally, like, you need to fix whatever is broken before you start using it again. Usually, like, if it's red, it's like there's something wrong, I cannot run at all. So I I don't think you should be like, using it anyway. Like if it's red, like you need to fix whatever the issue is. Next, Niter is asking, are there any plans to open source certain parts of the code, for example, under the components and Protoflux nodes so that the community can contribute to those? So there's some plans, nothing's fully formalized yet. We've kind of had like some discussions about it, so I'm not gonna go like too much super into details, but my general approach is like we would essentially do kind of gradual open sourcing, of certain parts, especially ones that could really benefit from community contributions. One example I can give you is, for example, the importer and exporter system, where, and also like the device driver like system, where it's very, what's the term, like ripe for like open sourcing, where we essentially say, this is the model importer, this is, volume importer, and so on. This is our, and this as, this is support for this format. And we cannot do this, like we make this like we make the code, open, which will allow for community contributions, so people could, contribute stuff like, fixes for like formats or some things importing wrong. Or alternatively, you want to add support for some obscure format that we wouldn't support ourselves, because it's, you're modding some kind of game or something and you want to like, mess with things. You can use the implementation that we provided as a reference, add another, importer or exporter. There's, or like if you want to like, you need to like, very specific fixes that are relevant to project you're working on, you just make a fork of one of the, one of ours, or even communities, and like, modify it for the purposes, and you make changes that wouldn't make sense to have like, in the default one, but like that are useful to you. So that's probably the kind of model I would want to like follow, at least like initially. We open source like, things like partially, where it kind of makes sense, where it's like also easy to do, because like open sourcing, that can be kind of complicated process, like if you want it for everything, because there's pieces of code that have like certain licensing, and we need to make sure like it's all compatible with the licensing. We need to make sure everything's kind of audited and cleaned up. So doing it like by chunks, doing just like kind of some systems, I feel it's much more easier and approachable way to start, and we can kind of build from there. The other part of this is, when you do open source something, you generally need like maintainers. And right now, like we don't really have like super good process, for handling kind of community contributions for these things. So that's something I feel we also need to heavily improve. And that means like, we kind of need to have prepared some manpower to like, look at the community like pull requests, make sure we have a good kind of communication there, and make that whole process kind of run smoothly. And there's been like, some PRs that like piled up against, like some of our projects, like some of our open source parts, and that we haven't really had a chance to properly look at because everything's been kind of busy. So I'm a little bit like hesitant to do it like, now, at least until like, we clear up some more things and we have like better process. So it is also like, part of the consideration there. But overall, it is something I'd want to do. Like I feel like, like you as a community, like people are doing lots of cool things and tools, like the modding community, they do lots of really neat things. And, doing the gradual kind of open sourcing, I feel that's a good way to empower you more, to give you kind of more control over these things, give you more control to fix some things. Because there's also like parts, like where we're small team, so sometimes like our time is very limited to fix certain like niche issues. And if you give people, the power to help contribute those fixes, I feel like overall, the platform and the community can benefit from those. As well as giving you ways to like, because big part of like Resonite's philosophy is, giving people as much control as possible, making the experience what you want it to be. And I feel, by doing this, if you really don't like, the way we do something, like, or how like, Resonite handles certain things, you can kind of fork that part and, make your own version of it, like, or fix up the issues. You're not as dependent on us, as you otherwise would have been. The flip side to that is like, and the part that I'm like usually kind of worried about is we want to also do it in a way that doesn't result in the platform, fragmenting, where everybody ends up, on a different version of the build, and then like, you don't have this kind of shared community anymore. Because I feel, especially at this stage, that can end up hurting the platform, if it happens, especially like too early. And it's also like one of the reasons, I was kind of thinking going with importers and exporters first, because those will pretty much, they cannot, cause fragmentation, because they do not fragment the data model. This just change how things are brought into or out of the data model. But, the actual behaviors, like it doesn't make you incompatible, with other clients. You can have like, importers for data formats that only you support, and still exist, with the same users, and be able to, join the same sessions. That's pretty much kind of, on the whole, like kind of open sourcing kind of thing. And that's the reason I kind of want to approach it this way, is like, take baby steps there, see how it works, see how like, how everybody kind of responds, so see how we, are able to kind of handle this, and then kind of, be like, okay, like we're comfortable, with this. We can now, take a step further, open source more parts, and just kind of, make it a gradual process, then like, just big flip of a switch, if that makes sense. So we have about 4 minutes left. There's no more questions, so like I might, I don't know if like this is enough for a ramble, because right now, I don't know like what I would ramble about, because I do like more Gaussian splats. I've already rambled about Gaussian splats a fair bit. If there's any like last minute question, I'll try to answer it, but I might also just end up like a few minutes early. Unless I end up rambling about rambling, which is some sort of like, meta rambling, which I'm kind of doing right now. I don't know, I'm actually kind of curious, like everybody, like, with the Gaussian splatting, is that something you would like to see, like you would like to like, play with? Especially if we can like, bring stuff like this. I can show you, I don't have like too many videos of those. I do have like one more, no, wait. Oh, I do have actually one video that I want to show. I do need to fetch this one from YouTube, because I haven't like imported this one in. Let's see. Oh, also like, no, actually, let me just do this first before I start doing too many things at once. There we go. So I'm gonna bring this one in. What? Once it loads. This one's from YouTube, so it's like actually a little bit worse quality. But this is another Gaussian splat that I did. Well, I have lots, but I need to make videos of more. This one I found like super neat, because like it's a pretty complex scene. This is from GSR at BLFC. You can see like it captures a lot of like kind of cool detail, but there's a particular part I want you to pay attention to. I'm gonna point it out in a sec, because one of the huge benefits of Gaussian splats is they're really good at not only soft and fuzzy details, but also semi-transparent stuff. So watch this thing. Do you see like these kind of plastic, well, they're not plastic, but like these transparent bits? Do you see these? Look at that. It's actually able to represent that like really well, which is something you really don't get with the traditional mesh-based photogrammetry. And that's actually one of the things, like if you wanted to represent it as a mesh, you'd kind of lose that. And that's why, like, why Gaussians are really good at representing scenes that traditional photogrammetry is not. And I found it like really neat. And we have also lots of like splats I done. Like this October, I was like visiting in the US, and I went to the Yellowstone National Park again. I have lots of scans from there. And like a lot of them kind of have like some, because there's a lot of geysers and everything, and there's actually there's like steam coming out of the geysers, and there's like water, so like it's reflective in some places. And I found with Gaussian splats that actually reconstructs pretty well. Like it even captures some of the steam in the air, and it gives it more of a volume. So they're like a really cool way, you know, of like representing those scenes, and I just kind of want to be able to, you know, bring that in and be like, you know, publish those on Resonite and be like, you know, you want to come see like, you know, bits of like, you know, Yellowstone, bits of this and that, you know, like just go to this world and you can just view it and show it to people. But yeah, that actually kind of filled the time nicely because we have about 30 seconds left, so I'm pretty much gonna end it there. So thank you very much for everyone, you know, for your questions. Thank you very much for like, you know, watching and you know, and listening, like my ramblings and explanations and going off tangents. I hope you enjoyed this episode. And thank you also very much, you know, for just like supporting Resonite, whether it's like, you know, like on our Patreon, you know, whether it's just by making lots of cool content or, you know, sharing stuff on social media, like whatever you do, you know, it helps the platform. And like, you know, we appreciate it a lot. So thank you very much, and I'll see you next week. Bye-bye. Bye. Warp.